This video is sponsored by Brilliant. Start your 30-day free trial by clicking my link in the description. Hello, my name is Mr. Asprey, the maths YouTuber with awesome ball knowledge, here to absolutely save your A-levels and get you the best grade possible. This is June 2023, this is EDEXCEL, and this is paper 1. And I've just finished the paper, and it is a good, fair paper with a couple of tricky questions in there, particularly the final one, really tricky, but also lots of parts to the question where you have to be really careful with your final answer. Give it in the correct form. Make sure you look at the wording like value versus values. Which value do you need to eliminate? Which one do you need to accept? Be very careful with your working and your final answer. So great paper. I've got all the questions coming up. I really hope you enjoy it, and I hope it's going to be helpful for your revision. And with that being said, something else which can be very helpful with your revision and also great for your problem solving skills is the website and sponsor of today's video, brilliant.org. Brilliant.org is a fantastic website that can really help improve your critical thinking and problem solving skills, which can be so helpful in the run up to exams. Brilliant.org is designed to help you build real understanding from the ground up. It's not about watching endless lectures. Brilliant's hands-on approach lets you play with concepts and problem solve, making it up to 6 times a more effective way of learning. Crafted by award-winning teachers and professionals from MIT, Caltech, Google and more, every lesson strengthens your critical thinking skills. It's not about memorizing facts, it's about becoming a better thinker. In just minutes a day, Brilliant helps you build real knowledge, whether it's during exam prep or on your daily commute. Brilliant makes learning easy, fun and accessible. And try everything Brilliant has to offer free for a full 30 days. Just visit brilliant.org/Mr. Asprey or scan the QR code on screen, or you can click the link in the description. You'll also get 20% off an annual premium subscription. Right, let's get into the maths. Okay, question 1, let's get it. And we have an integral. So I'm integrating. And in fact, what I'm going to do first, let's take out that third. And then I'm going to have x to the half and then 2x minus 5. Now you can take out a constant term, so a term which doesn't have an x in. You can take that out of the integral. Sometimes it makes it easier. So this is going to be, when I multiply out these brackets, when I times those two x terms together, I'm going to get 2x and the powers are going to add, so that's 3 over 2. And here I'm just going to get minus 5 lots of x to the half dx. Now I should put this in brackets as well to show that the whole integrand, which is the function we're integrating, is in terms of dx. Okay, great. So now we need to just integrate. So once I've done my integral, my integration, I just put it in square brackets. So the power goes up by 1. So the power changes to 5 over 2. Just add 1 to the power. And then I'm dividing by that new power. So I'm dividing by 5 over 2, which is the same as timesing by 2 over 5. So that gives me 4 over 5 when I also times by the 2 here. And again, I'm going to do the power first. So up the power by 1 gives me 3 over 2. And then I divide by 3 over 2, which is the same as timesing by 2 over 3. Times that by 5 gives me 10 over 3. Okay, lovely. And then plus c as well. And then I'm just going to multiply by the third. So I'm going to get 4 lots of 15ths, x 5 over 2, x to the 5 over 2, minus 10 over 9, x to the 3 over 2, and then plus c. And that is good for 4 marks. Thank you very much. Bish, bash, bosh. Question number 2. I'm over the other side. What I'm trying to do is make sure that you can see all of the question and the working. Hopefully that is the most helpful way. Do let me know if you've got any suggestions about how best that I should frame this these walkthroughs. Anyway, question 2, part A. Okay, so it says that we've got a function, lovely. A is a positive constant, I'm sure that'll be useful, and we know that x minus a is a factor of f of x. Well, by the factor theorem, if x minus a is a factor of f of x, then it means that f of a is equal to 0. So basically, I sub in a and I get 0. So let's sub in a. So that gives me 4a cubed plus 5a squared minus 10a plus 4a, and that equals 0. Yeah, looks good. Okay, great. We can tidy this up a bit by collecting up the a terms. That's going to give me minus 6a. And then finally we can take out a factor of a because all three terms include at least a. So that gives me this, and then that, and that equals 0. And I believe that is exactly what we have been asked to prove. So that is good. And that is part A done. Okay, lovely. Right, now we can move on to part B. And it says, hence find the value of A. Right, so we're going to have to solve this equation, aren't we? Now, I mean, you could use your calculator here to solve. It does say solutions relying entirely on calculator technology are not acceptable. So I might be a little bit wary of that. So in fact, what I'm going to do is I'm just going to solve that quadratic using factorization. So the a and the c term are 4 and minus 6, which gives me minus 24, and the b term is 5. So two numbers that times together to make minus 24 and add to make 5 are 8 and minus 3. So this is how I do it. I write 4a here. Those two numbers again were plus 8. And I write 4a again, and then minus 3 was the other number. And then I divide the whole thing by 4. This is what works for me. This is how I solve quadratics by factorization. Okay, great. So how can I divide all these brackets by 4? Well, I can just divide this one here by 4, and that will cancel out the divide by 4 there. So this gives me a plus 2, and then 4a minus 3 equals 0. Great. And that tells me that a is equal to 0, or a is equal to minus 2, or a is equal to 3 over 4. Brilliant. Okay, now the most important word in the whole A level is this one here, value, because it says either value or values. And this one's a singular, which means there's only one solution. So I'm going to circle the correct one, which is going to be this one. And that is because it says that a is a positive constant. Okay, so positive means greater than 0. So not 0. 0 is technically not positive or negative. And minus 2 is definitely not positive. So that is going to be our answer, 3 over 4. Great. Okay, on we march to 2C. And it says use algebra to find the exact solutions of this equation. So f of x equals 3. Okay, so let us write out f of x as given at the top of this question. Now what is this part here? 4a, well that's 4 times by a, and a is 3 over 4 as we've just shown. So this just gives me 3. Okay, so we've got plus 3 and that equals 3. Okay, great. So what we could do next is we can just simplify this by subtracting 3 from both sides. Brilliant. Okay, let me just grab some more space. And then what we can do is we can take out a factor of x. Yeah, so 4x squared plus 5x minus 10 equals 0. Now this one I can't factorise. It does again say that solutions relying entirely on calculator technology are not acceptable. So again, I would be reluctant here just to slam this into my calculator. And in fact, I would want to show how I've come about finding these solutions. So what I'm going to need to do is use the quadratic formula for this quadratic here. So in doing so, I could say that here we get x equals 0. And from this quadratic, we get x is equal to minus b, which is minus 5, plus or minus the square root of b squared minus 4 times by a times by minus 10, which is c. And that's all over 2 lots of a, which is 4. Okay, great. And then from there, that simplifies down to minus 5 plus or minus the square root of, inside that bracket I get 185, and that's all over 8. Okay, so there we have it. Those are the three solutions. We have x equals 0, and we have these two solutions here, minus 5 plus or minus root 185 over 8. Okay, that sounds good to me, and that is question 2 done. Question number 3, we've got vectors question. We've got the position vector of 2 points, A and B. Even though A, we don't know all of the coordinates. A is a positive integer, again, that's probably going to be useful. Show that the magnitude of the position vector of A is equal to root 38. Okay, so that should be relatively straightforward, given that we know all the points, and to find the magnitude of a vector we use Pythagoras. So we square root, whoops, let me do that a bit neater. Yeah, we square root the components squared and added together. So 5 squared plus 3 squared plus 2 squared, and that's equal to root 38. So that's it, job done. Okay, so next one, find the smallest value of A for which the magnitude of the position vector of B is greater than the magnitude of the position vector of A. Okay, so the first thing we're going to need to do is find an expression for the position vector of B's magnitude. And we'll do that by, again, using Pythagoras. So it's got 2 squared plus 4 squared plus a squared, and that's equal to the square root of 2 squared plus 4 squared is 20, and then plus a squared. Okay, so what do we need? We need that expression to be greater than the square root of 38. Okay. So the only way this can happen, because the magnitude is always positive, so both of these expressions are positive. So the only way this can happen is if, well, the left-hand side is bigger than the right-hand side, basically. So 20 plus a squared needs to be greater than 38. Okay, so that tells me that a squared needs to be greater than 18 by subtracting 20 from both sides. Okay, let's move up over here. So that means that a needs to be greater than the square root of 18. So a needs to be greater than it says the smallest value of a. We need to be careful here because it says that a is a positive integer, and we want the smallest one. Okay. So we need to know exactly what that value is. So here, being exact value is not actually useful. So if I type it into my calculator, I get about 4.24. So because a is a whole number, and we want it to be as small as possible, but it's got to be greater than 4.24, then a we're looking for is 5. Perfect. That does the job nicely and is correct. Yay! Okay, question number 4, and we have the derivative function. It's important to note that that's the derivative because there's a dash there of this original function. Okay, so we know the derivative. It says the curve has a stationary point with x coordinate alpha, and alpha is small. Use the small angle approximation for cosine x to estimate the value of alpha to 3 decimal places. Okay, so we know that if we want to find x, because it's at a stationary point, then the derivative function, which is this, is equal to 0 at that point. So we need to say that the derivative function is equal to 0. Excuse me, let me just move that over, and right here, this is part 4a. So we know that 2x plus half of cosine x needs to be 0 at this particular point. Okay, and then because at that particular point the x coordinate is alpha, we can say that this is 2 alpha plus a half cos alpha, like so. And then also, because alpha is small, we can use the small angle approximation for cosine. And that small angle approximation is 1 minus, in this case, alpha squared over 2. So that is the small angle approximation for cosine. Again, that's in your formula book. Okay, so now we just need to solve this and see what happens. So that gives me a half, and this gives me minus alpha squared over 4 equals 0. I can then multiply by negative 4. So that would give me minus 8 alpha plus minus 2, and then plus alpha squared, and then I could just write that like so, and that's a quadratic I'm used to solving. And in order to solve that, again, I would just use the quadratic formula. Again, I know it says that solutions relying entirely on calculator technology are not acceptable. That would be you using like the CG50 to solve that equation, as opposed to just solving a quadratic using your calculator. You can solve quadratics using your calculators, no problem. So I'm just going to go straight to the answer here, and that would be alpha is equal to, well, in fact, there's going to be 2 answers, isn't there? Because this is a quadratic, of course. So there's only one answer for me to give, because again it says the value of alpha, not values. So I need to pick the one which is small. So of the 2, I'm picking the one which is small, and that one happens to be minus 0.243, and that is because as alpha is small, you can reject the other one, which I don't even know what it is, to be honest. Okay, lovely. Let me grab some space. Okay, 4b, it says the point 0, 3 lies on C. Find the equation of the tangent to the curve at P, given your answer in the form y is equal to mx plus c. Well, because we know that the tangent goes through P, and P is actually on the y-axis, I know straight away what the y-intercept is. So the y-intercept is 3. So I know the c value. But what I don't know yet is the gradient of the tangent. But the gradient of the tangent is the same as the gradient of the curve. And when the x-coordinate is 0, then we can find the equation, we can find the gradient by just subbing into the gradient formula. So I need to find f dash of 0, which is 2 times by 0, again, this is just using this equation at the top here, plus a half cosine of 0. So 2 times 0 is obviously 0, and cosine of 0 is 1, so times that by a half is just a half. Okay, so therefore the tangent at P is given as y is equal to the gradient is a half, and the intercept, like I said before, is 3. Okay, so that will do the job. That is our final answer. And that is another question done. Lovely. Question 5 is a trapezium rule. So we're going to need the formula for the trapezium rule, which is the height or the width of the trapezium over 2, and then multiplied by the 2 endpoints plus 2 times any of the middle points. So with that being said, the height is the gap in between the x's, which stays consistent, which is 0.2. The endpoints are a and 13.5, so 13.5 plus a. And the middle ones are, well, these 3 in the middle here. So that's 2 lots of the middle ones, which are 16.8 plus b plus 20.2 plus 18.7. Perfect. Okay, and we are told that the given area is 17.59. That is 0.1. And then we could do a little bit of tidying up. So let's add together 16.8, 20.2 and 18.7. And that gives us 55.7. So we have b plus 55.7. And then we can times both sides by 10 to get rid of that 0.1 there. So that gives us 175.9 is equal to, and now we've got 13.5 plus a plus 2b plus timesing by 2 is going to give me 111.4. Okay, perfect. So all I need to do now is just subtract 13.5 and 111.4 from 175.9. And when I do that, I get 51. So that leaves me with 51 is equal to a plus 2b, which is exactly what they want. In fact, they just want it written slightly differently. So a plus 2b is equal to 51. Perfect. So that is part A done. Part B, it says, given also that the sum of all the y values in the table is 97.2, find the values of a and b. Okay, great. So we can do the a plus b plus all the other y values that we know, which are this one, this one, this one, and this one. Let's add those up. So I'll just do that on my calculator now. What do I get when I add them all up? So that's going to equal 97.2, and then when I add up those numbers, I get 69.2 is equal to 97.2. So this gives me that a plus b is equal to 28. Bosh. Okay, so we've got two. We've got a pair of simultaneous equations that we can solve. So we've got this one, and we've got this one. Okay, so let's just line up these simultaneous equations. I've got a plus 2b is equal to 51, and I've got a plus b is equal to 28. The a is already perfectly lined up, so let's just subtract. Gives me b is equal to 23, and then I know that a plus b is 28, so therefore a must equal 5. And we are done. Is that final answer? Lovely. Question number 6, and we've got logs. We've got an expression for a and b, and it's asking me to find an expression for log base 2 of the square root of x. Well, we can say that this is the same as log base 2 of x to the power of a half, because the square root of x is the same as x to the power of a half. And using log rules, we can bring a power down to become the coefficient. So we get this, and that is a perfect match for this guy here. So we can just substitute that in, and that's going to give me a half of a. Perfect. Okay. Part B, a bit trickier, but we've got log base 2 of x squared plus 8x. So we can, when we have two logs added together like this, then there's not much we can do. We've got to take out a factor. That's what we've got to do. So this is log base 2 of x multiplied by x plus 8. Okay, this is good because when we've got two logs and the input is times together, that's when we can split it up into two individual logs. So we get log base 2 of x plus log base 2 of x plus 8. So that's making use of the log rule, which is that log AB is equal to log A plus log B. Okay, great. So what can we do now? Well, in fact, this is already in the form like we want A, and this is already in the form that we need for B. So great. This is just simply A plus B then. Okay, so that is correct. Lovely. And then let's move on to part C. So part C is similar in that you have this log with two things added together, just like we did in part B. And what we had to do is we had to take out a factor to turn it into something which looks like this. And you can kind of see a little bit of similarity in how we can kind of get there. If we divided by 8 and times through by x, I think we would get there. So we can say that this logarithm is equal to two things times together. So that would be 8 over x, yes. And then if we multiply that by our x plus 8, we should get there. Let's try the first one. The first one, when we times those two together, we get 8, good. And then the second two, when we times those two together, we get 64 over x. Lovely. So now we can split this up into two separate logarithms using that log rule again. Whoops. Log base 2 x plus 8. Okay, and then this one up here is this one here. So we know what that one is already. And it's just this final one, or this one here, that we need to sort out. But that is the same as log base 2 of 8 minus log base 2 of x. And then we still have this as well. Okay, so I think we're looking good now because we have this one and we also have this one we know as well. It's this one at the start. And then log base 2 of 8 is just 3. So it's 3 minus a plus b. Job done. Lovely. Okay, question 7, and we're looking at functions. So 7 part A is asking us to find the range of f. Well, we know that a square root is always positive, And if we're inputting numbers greater than 2, that means that this is going to give us values greater than 0. Because when you sub in 2, you get 0, and then you sub in numbers greater than 2, you will get numbers greater than 0. So that means that the range, which we always write f of x, is going to be greater than 3, but not equal to, because again, this can never be 0, because this tells us that we can't sub in x equals 2 exactly. So it's always going to be greater than 3, because this will always be positive, but it can't be 0. Okay, good. Next, find the inverse function. Okay, so we're going to do the trusty old method, which is setting it equal to y, like so. And then we're going to swap over the x's for the y's, like so. And then we're going to rearrange so that y is again the subject. So I will subtract 3, which gives me this. We'll square both sides, which gives me this. And then we'll add 2 over, so we get x minus 3 all squared plus 2 is equal to y. And then finally we'll notate it correctly by saying the inverse function is equal to x minus 3 all squared plus 2. And then the final thing to do is we need to check out the domain of the inverse function, which is the range of the original function. So we will say for x values that are greater than 3, because that is the same as the range of the original function. So yes, when you work out the inverse, you do have to give the domain to get full marks. Okay, let's move on. Okay, part C, and this looks like a composite function. We are looking at g of f of 6. So the first thing I would need to do is find f of 6, which we will find by putting 6 into f. So that's going to be 3 plus the square root of 6 minus 2, which is 3 plus the square root of 4, which is 3 plus 2, which is 5. Okay, great. So now to work out g of f of 6, that's the same as just g of 5, because f of 6 is 5. And g of 5 means putting in 5 into the function g. So that's going to be 15, x is 5, minus 3. So that is 15 over 2. Perfect. So that's our answer, just 15 over 2. Yes. Okay, what's next? Find the exact value of the constant a for which when I sub in a squared plus 2 into f, it equals g of a. Okay, well let's just sub in. So when I sub in to f, I get 3 plus the square root of x is now a squared plus 2, and then there's also a minus 2 there as well. That comes in here. And we're saying that needs to equal g of a, which is 15 over a minus 3. Okay, so let's solve that for part B then, part D, sorry. Okay, let's start with the square root. Let's tidy this up a bit. So we get 2 and a minus 2, which is just 0, and then a squared square rooted is just a. Now, I'm sure some people might think, well, why is it not plus or minus a? And that's because the function is defined as the positive square root. So we're only taking the positive square root. It's only when you square root an equation do you then yourself have to input x plus or minus. In this case, the square root is clearly defined as positive. So we're only taking the positive value. And that's equal to 15 over a minus 3. Okay, so we're going to multiply up, and we're going to get 3 plus a multiplied by a minus 3 is equal to 15. we need to expand out these brackets. So that's going to give me a squared. Oh, it's a difference of two squares actually. Nice. So that's just a squared minus 9. That equals 15. So therefore a squared is equal to plus the 9 over, it's going to give me 24. So finishing up here, that gives me a is equal to plus or minus 24. It does say the exact value, so that means that I can't have a plus or minus here. So I have to think about why I have to get rid of one of the values. And I'm going to say that I need to get rid of the negative. And the reason for that is that when this function always gives us positive values, we actually worked that out at the start of the question because we said the range was f of x is greater than 3. Now, if I have so that's regardless of what the a value is. Now, g of a, if a was negative, then g of a would also be negative because we'll be doing 15 over a negative value if a was negative. So that means that the left-hand side would be positive and the right-hand side would be negative, which is not possible. So with that being said, it's only the positive square root which is an acceptable answer. So simplifying the third gives us 2 root 6 as our final answer. So really important to read the question because it does say value, so that gave us a little hint as to which one to reject. Okay, question 8, let's go. So we have this stage and we have looks like all the information, and it says show that OC is 12 meters. So OC being the radius of that sector. Well, we know the arc length of the sector, so we should be able to use that to work out the radius because we also know the angle of the sector. Perfect. Okay, let's not do it up there, let's go here. So the arc length is equal to r theta, and we're told that the arc length is 27.6, so that's equal to r multiplied by theta, which is 2.3. So to find r, we need to do 27.6 over 2.3, which is an answer of 12. And that will be in meters. Okay, good start. Show the size of the angle AOB, so we're looking at this one in here, is equal to 0.421 radians. Well, we're assuming that's a straight line. It does say it's a straight line, so we can just, which has angles of pi on a straight line. So because of the symmetry, we can say that the angle AOB is equal to pi minus the 2.3 radians and then split between the two sides evenly. And that gives us an answer of 0.421 radians. Okay, so far so good. What are they going to throw at us next? Okay, so part C, and all of this yellow part is 35. So let's work out this distance here, which is going to be the same by symmetry of this distance here. So we can do that by doing 35 minus the 27.6 and then divided by 2. And that will give us a value of 3.7. So that's essentially the side BC. So therefore OB, so the whole side of this triangle here will be 12 plus the 3.7, because we already worked out that that radius there was 12, so this is going to be 15.7. Okay, we also know this side by symmetry is half of 15, so 15 over 2. And we also know this angle in here, we worked that one out already. So with all of that information, we should be able to work out the area of that triangle. So the area of the triangle, which is AOB, is equal to 1/2, and this is the formula for a triangle. It's a half of 2 of the sides multiplied together times by sine of the angle in between them, which is 0.421. Okay, so when we do that, we get an answer of 24.06. And the next thing we can try and work out is the area of the sector, because so far we have worked out this triangle, which is of course going to be the same on this side as well. So all we need to do now is work out the area of this sector. And the area of a sector is a half r squared theta. So that's going to be a half multiplied by the radius, which we worked out was 12. And the angle is 2.3. So doing that gives us 165.6. Okay, great. So the total area is going to be the sector plus 2 of the triangles. So the total area which we're looking for is going to be the triangle times 2 plus 1 of the sectors, or the only sector. And when I do that, I get 213.72, and it says the nearest square meter, so that is approximately 214 meters squared. Bosh. Love that. Okay, question number 9, and we have a geometric sequence. Part A says show that K satisfies this equation. Okay, well, if we have a geometric sequence, then we need to multiply by r to get from one to the next. So that means that if you take the second term and divide it by the first term, then that should give you r. But it also means that if you take the third term and divide it by the second term, so the one before it, that should also give you r. So it means that when I divide the second by the first and the third by the second, I should get the same thing, so I can set them equal to each other. Okay, so now let's just do your classic algebra technique. Multiply the denominators up to the other side, which gives me 12 minus 3k times by itself, and it gives me k plus 16 multiplied by 3k plus 4. Let's expand these out. 144 minus 3 times 12 is minus 36. Double it gives me minus 72k. And then minus 3k all squared is 9k squared. This is going to give me 3k squared. And then I'm going to get a 4k and a 48k, which makes a 52k in total. And then the last term, 4 times 16 is 64. Okay, brilliant. Let's move it all over to one side. We might as well pick the side with the greatest k squared. So take away 3k squared from both sides. Take away 52k from both sides. And then take away 64 from both sides. Gives us this. And then finally we can divide that through by 2. And we get as required, I believe. Lovely. Splendid. Okay, given that the sequence converges, find the value of k giving your reason for your answer. Okay. Well, the first thing I'm going to do is I'm going to solve that quadratic. And I'm going to do that now. Okay, so factorising. I'm just going to use my funky method for factorising, which looks like this. And the AC term is 3 times 40, which is 120. So the two numbers that times together to make 120 and add to make minus 62 are minus 2 and minus 60. And then we divide through, take out that factor in the second bracket, divide it by 3. So there we go, we factorised. So that means that k is equal to 2 over 3, or k is equal to 20. And once again, this is the most important word in A-level maths, value as opposed to values, which means that there's only one which is correct. Now, that is going to depend on what the R value is. So remember when we started this question, I said these two things were equal to each other, and that is because they are both equal to R. We also know that R, in order for it to converge, R needs to be between, or the magnitude of R needs to be less than 1. So it has to be in between minus 1 and 1. So let's check by substituting in. So let's try first k is equal to 20. It's probably the easiest one to sub in. So R would therefore, and I'm just going to sub into this one up here, so it'd be 20 plus 16 over 12 minus 3 times 20, which is 60. So this gives me 36 over negative 48, which is minus 3 over 4. Okay, so that's good. That the magnitude of that is less than 1, so therefore this is our guy. And I guess it does say give reason for your answer. Is that enough? I mean, in an exam, I would definitely chuck in the other one just to double check. So I would say try k is equal to 2 over 3, and that would give me R is equal to 2 over 3 plus 16 over, and then 12, and minus 3 times 2 over 3 gives me minus 2. So this would give me an R value of 16 and 2/3 is the same as 50 over 3 over 10, which is the same as 5 over 3. Which is not less than 1. Its magnitude is not less than 1. So therefore this one works, and that is because the R value is less than 1. Great. So I'll just write that out just to make sure that the examiner knows exactly what I'm doing, and I would say k equals 20 gives R equal to minus 3 over 4, which the magnitude of is less than 1, therefore the sequence converges. I want to make sure I get all my marks. And then finally it says find the sum to infinity. Okay, that's no problem. The sum to infinity is a over 1 minus r. The first term, if we look back up here, is 3k plus 4. So k being 20, 3k plus 4 is 64. And the r value is 20. So this gives me 64 oh no, sorry, the R value is not 20. Silly, silly me. The K value is 20. The R value is minus 3 over 4, as we found out. That makes more sense. So this is a total of 7 over 4. And this will give us a value of 256 over 7, which is our final answer. Lovely. Okay, question 10, we've got a circles question. And it says, find in terms of K the centre and the radius. Lovely. So some nice easy marks here. We've got x squared. I'm just going to put the x term next to it, like that. And then I've got the y squared, and I'm going to put the y term next to that as well. And then I'm going to move the constant term to the other side. Okay, next we're going to complete the square. So when we complete the square, we always look at the b term, or the term which is multiplied by the x. So in this case, the b is equal to 6k. So then we half that, which gives me 3k, and that's what we're going to use. So we say x plus 3k all squared minus, always minus, 3k all squared, like that. Okay, now let's look at the b term for the y's. That's minus 2k. So that's minus 2k, so we're going to half that, and that just gives us minus k. So we write y minus k all squared minus, always minus, minus k all squared, and that is going to equal minus 7. Okay, great. So now we can write these squared terms next to each other, like so. And then what we're going to get, we're going to get minus 9k squared, and we're also going to get minus k squared. So finally I can move those terms over to the other side. They're going to become positive terms, and they're going to be add to make 10k squared, and then that minus 7 is still there. Okay, so now we can actually answer the question, because we've got it in that form. We can say that the centre is essentially the solution to that bracket. So what makes that bracket 0? And that is when x equals minus 3k. And then what makes this bracket 0? That's when y is equal to k. So the coordinates, therefore, of the centre are equal to minus 3k, k. And the radius, well, this part of the equation is r squared. So the radius is therefore the square root of that expression, which is 10k squared minus 7. Lovely. That's job done. Can circle up our answers. And they are correct. Bosh. Okay, part B, and it says the line with this equation, y is equal to 2x minus 1, intersects C at 2 distinct points. Find the range of possible values for k. Okay, well, I've got rid of the completed to square form, but that's fine. We can just use this original form, which is actually easier to substitute into anyway. So let's do that. Let's substitute this line into that circle to find the intersection points. So I'm going to write x squared, and instead of a y squared, I'm going to write 2x minus 1 squared, plus 6kx, and then minus 2k, and then instead of y, we're going to use 2x minus 1, plus 7 equals 0. Great, so let's just expand. This is going to give me 4x squared minus 4x plus 1, and that's going to be plus 6xk, and this is going to be minus 4xk or kx, and that's going to be plus 2k because the double negative, and then we're going to get plus 7, and that equals 0. And now, because we're going to be checking the discriminant, because we got told this information that there are two distinct intersection points, I need to write this quadratic so that it's in the nice form ax squared plus bx plus c. So let's collect up the x squareds, and then let's collect up the x's and see what we've got. We've got minus 4, we've got a plus 6k, and we've got a minus 4k. So those last two, plus 6k and minus 4k, that makes plus 2k. So what we have altogether, we have plus 2k minus 4, that's how many x's we have. So just to clarify, there's 6k minus 4k, that's 2k, and there's a minus 4. So altogether that's how many x's we have. And then let's look at the constant terms. We've got a 1 here and a 7, that makes 8. So we've just got 2k plus 8, and I'll just put that in a bracket as well so it's nice and clear to see that this is our A term, this is our B term, and this is our C term. And that's equal to 0. Okay, so now what we can do is we can check the discriminant. Because we have two distinct intersection points, that means that the resultant quadratic that is formed should have two real roots, which means its discriminant is greater than 0. So let's take the b and square it, and then let's minus 4 lots of the a, which is 5, and times by the c, which is 2k plus 8. And that needs to be greater than 0. Okay, let's expand on this bracket. That gives me 4k squared, that gives me minus 16k, and that gives me plus 16. And then here we've got minus 4 times 5 times 2k, which is minus 40k. And then we've got minus 4 times 5 times 8, which is minus 160. Yes, and that needs to be greater than 0. Okay, let's collect up. We've got 4k squared, we've got minus 56k, we've got minus 144 greater than 0. And then we can divide through by 4 to get k squared minus 14k minus 36 is greater than 0. Okay, right, I don't think that factorizes, so I'm just going to go to my quadratic solver. Okay, and I'm going to take advantage of the class whiz here, and I'm going to go to inequality degree 2, and this is a greater than 0, so number 1, and then I'm going to type in 1k squared minus 14 minus 36. And look at that, it gives you it nicely. So the values for k are that k is less than 7 minus the square root of 85. Put that in a set. Union, because these are two separate inequalities, k is greater than 7 plus the square root of 85. Okay, so that's beautiful, and that is question finished. Wallop. Logs. Yay. I was being sarcastic, by the way. Okay, let's do this then. Logs. You've got a formula, that's nice, and you have a graph, that's helpful, and you've got points on the graph, and it says find the initial value of the phone. Okay, so the initial value of the phone is when t is equal to 0, and just reading off the graph, when t is 0, we have up here that the variable base 10 of v is equal to 3. So what is a logarithm? Well, logarithm has a base, and that's 10, and so that means that 10 to the power of the answer is equal to what you're inputting into the logarithm. So 10 to the power of 3 is equal to the particular value we're looking for, so that's equal to £1,000. That was a pricey phone. Okay, part B. Find a complete equation for v in terms of t, giving your the exact value of a given and b to three significant figures. Okay, so this is how I do these log questions. I do it like this because, well, I just find it easier, and once I know how to do it this way, I don't really need to know anything else. So I take logarithms of the formula that you're given, so it's in this term, and then we can split this up into, using log rules, that these two things are multiplied together, the inputs multiplied, so we can have that as log a plus log b to the t, and we can also use another log rule, which is bringing the power down to become the coefficient, like so. And then what I do is I look to see what the variables are that we're using with. It's t and it's log v. So this is a variable and t is a variable. So let's just rewrite it in the form that we're used to seeing when we have a straight line. And that is like this, where we have a variable here and here. So this is very much like what we see when we see y is equal to mx plus c. Okay, so this is our y variable, this is our x variable, and what that means is this is our gradient, and it means this is our intercept. Okay, so as long as we know our gradient and our intercept, then we can find the values of b and a. So let's first off find the gradient, and we'll do that by, let's do it up here actually. Okay, so the gradient, let's call that little m, and that's going to be the change in the y over the change in the x. Okay, great. So that gives me minus 0.21 over 10, which is equal to minus 0.021. Okay, so we've got the gradient and we've got the intercept. So we should be good to go. So let's scroll down here. Now the gradient, as we've paired them up, is the same as log 10b, and that was equal to minus 0.021. And the intercept is the same as log 10a. I forgot to write the log 10 there, but you know, that's fine. And that's equal to 3. Okay, great. So let's reverse engineer this to get that b is equal to 10 to the power of minus 0.021. Checks notes, and that value is 0.953. And we've already done this calculation. A is equal to 10 to the power of 3, which is 1,000. Perfect. Okay, and now it says exactly 2 years after it was bought, the value of the phone was £320. Use this information to evaluate the model. Okay, so the value of the phone using this model up here is equal to A, which is 1000, multiplied by B, which is 0.953, to the power of T, which is, be careful, it's measured in months. So therefore T is not 2, it's actually 24. So it's the power of 24. Okay, so we can work that out, and that gives us a value of 314.9. And that's pretty good, really. After 2 years, that is pretty close. So we can say that is approximately 320, and therefore this is a good model. Perfect. Okay, we've got a standard one here where we have y equals sine x, and we're using differentiation from first principles to show that the derivative of sine is cos. And it says that you may use some of these things without proof, which is lovely. Okay, 12. So first off, let's just remind ourselves what the formula is for the derivative function via first principles, and that is the limit as h tends to 0 of f of x plus h minus f of x all over h. So that's given in our formula booklet. And what I'll do over the side here is I will just say that f of x equals sine x. So therefore let's figure out what f of x plus h is equal to. Well, that will be sine of x plus h, and we will therefore use the so-called the compound angle formula, which we can just write here is sine A sine B. No, it's not. Sorry. It's sine A cos B plus sine B cos A, or something of that nature. Yes, that is correct. So that gives me sine x cos h plus sine h cos x. Okay, great. So we can substitute this in now. So that's the limit as h tends to 0. So we're going to sub that straight in. So that's sine x cos h plus sine h cos x, and we're minusing the function f of x, which is sine x, and then we're dividing that all by h. Okay, now the trick here is to take out a factor so that we're left with those things that go to either 1 or go to 0. So what we're going to do is we're going to take out a factor of, we're going to look at these two terms, the ones that have a sine x in actually, and we're going to do these two separately. So this is sine x, and then what we can do is we can open up a bracket, and we have cos h minus 1, and then we can divide the whole thing by h, or just this by h. Okay, so let's just make sure that's correct. Does what I've written here multiply out to give us the blue part of this expression? Well, we're going to get sine x cos h, and then we're going to get sine x minus times by minus 1, which gives us minus sine x, and that's all divided by h, which is correct. Okay, and then the other term is we can take out a cos x, and this is the, let's call this the yellow term, which is also divided by h. So I can just take out a cos x, and that will give me sine h over h, like that. and technically, because I've split it up into two separate fractions, I should put a big bracket around so that it's clear that the limit is being applied to both of those two fractions. Okay, lovely. And now all we can do is we can say, as h tends to 0, sine h over h tends to 1, and cos h minus 1 over h tends to 0. This gives that f dash of x is equal to, well, let's have a look at this. We've just said that this part here is going to tend to 0. So therefore we're going to have sine x times 0 plus cos x, and we're told that this one here is going to tend to 1, so that's 1, so it's cos x times 1, which gives just cos x. So we're good. We have proven that it tends, well, not tends, but it converges, it arrives at cos x. Beautiful. Okay, just final point there. It does in the question actually say dy by dx equals cos, and I know that I've given my final answer as f dash of x equals cos. Luckily the mark scheme condones it, but it was a little bit sloppy on my behalf. I should really say dy by dx is equal to cos x as my final statement, but the mark scheme was allowed me. Okay, question number 13. And we have lots of information here, so give that a read. But most importantly, we have a function, and it then says find a complete equation for the model. Okay, so we need to find two constants here, a and b. So we have to use each of these bullet points. So we're going to start off with the maximum height. Now, when a quadratic is at its maximum, then it's easy to find that using completing the square, which luckily this is already in. So at the maximum, we will know that we want to take away as little as possible. So this square bracket here, the smallest it can possibly be is 0. So therefore, max height occurs is when we have t is equal to 20. So therefore, because that makes this bracket 0, and that's good for us, we want to take away as little as possible. So 60 is equal to a, that's it, because we have minus and that bracket is 0, so 60 is equal to a. Okay, great. So now we need some more information, and that is that the carriage starts a circuit at a vertical height of 2 meters. So that means that h is equal to 2 at t is equal to 0 when it starts its circuit. So subbing into the formula, it gives me 2 is equal to a, which we know is 60, minus b, and t is 0 in this instance, so minus 20 squared. So 2 is equal to 60, and that will be 400, so minus 400b. So therefore b is equal to 58 over 400, which is equal to 29 over 200. It does say find a complete equation for the model, so it's not enough just to find a and b. You have to then put it all together and say that the model is h is equal to 60 minus 29 over 200, open brackets, t minus 20 close brackets squared. And that is our final answer. Bosh. Okay, part B, it says use the model to determine the height of the carriage above the ground when t is 40. Okay, so we're just going to substitute in t is equal to 40 into the formula which we've just created. So when t is 40, that bracket becomes 20. So we're timesing through by 400, which gives me 60 minus 58, which is equal to 2, and that is measured in meters. So 2 meters is the answer there. Okay, great. And then let's go on to part C. It says an alternative model, blah, 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 it's given by that. Find a complete equation for the alternative model. Okay, so let's then, again, let's do the same thing really. Let's look at when h is at its maximum. So there's a function of cos there, and cos has a maximum output of 1. So at h max, we're going to get 29 times by 1 plus beta. And we know that the h max is at 60 from before, so we get this. So that tells me that beta is equal to 31. Okay, and then we're going to use the same thing as we did last time, that t is equal to 0 gives a height of 2 because it starts its circuit at a height of 2. So that tells me that 2 is equal to 29 cos of alpha plus beta, which we know is 31. Okay, so take 31 from both sides, gives me minus 29 is equal to 29 cos alpha. Divide through by 29 gives me minus 1 is equal to cos alpha. So alpha, which is between 0 and 360, cos is at minus 1 at 180. So alpha is 180. And then finally, once again, it does say give the complete equation, so you have to write it out like so. So that's cos of 9t plus alpha, which is 180, and then plus beta, which is 31. Okay, great. What an interesting question, like 2 exact same methods. Okay, part D says that given that the carriage moves continuously for 2 minutes, then which one would be the most appropriate? Well, 2 minutes, let's just remind ourselves, t is measured in seconds, that's 120. And also, let's just remind ourselves what happened when we had t is equal to 40 for the quadratic. So for the quadratic, we had t is equal to 0, gave us a height of 2, and we also had t is equal to 40, gave us a height of 2. So by being quadratic, it's going to carry on going down and down and down, because this is a negative quadratic graph. So let's say it started at 2 and it got to 2 after 40 seconds. It's going to carry on going down, which is unrealistic. So the trigonometric one is better because it allows for more than just one circuit. So we can say alternative model is better. Apologies for the handwriting. As allows for more than one circuit. and quadratic is only good for 0 to 40 seconds. Okay, good. Actually, as the values become negative some time after t equals 40. Yes, make sure to get those marked. Okay, question 14, and we have prove using algebra that this is odd for all n. Okay, so what we're going to do is we're going to let n equal 2k, where k is an integer. Okay, or in fact let's use natural number because they've used a natural number there. So just in case you're not aware, natural numbers are all positive integers other than 0. Okay, so this basically is me saying n is an even number because any even number can be written as 2 times any number. So then what that allows us to do is it allows us to therefore check to see if even numbers, when substituted into this formula, give even answers, or odd answers is what we're actually looking for. Okay, so in doing this, expanding out a triple bracket, I'm going to use binomial. So we have one lot of 2k cubed. And remember, Pascal's triangle for the third row looks like this. So we're going to have 3 lots of 2k squared times 1 to the power 1, plus 3 lots of 2k to the 1 times 1 squared, plus 1 lot of just 1 cubed. And then minus 2k all cubed is 8k cubed. So let's tidy this up. That's also 8k cubed. Okay, and then we get 2 squared is 4 times 3 is 12, and then there is a k squared there, times 1 just stays the same. And then we've got 3 times 2k, which is 6k, and then again times by 1 squared stays the same, plus 1, and then minus 8k all cubed. So these cancel out nice and neatly. So that leaves me with 12k squared plus 6k plus 1. And we know this is odd because we can take a factor of 2 out of the first 2 terms and leave plus 1. And that is a classic odd number because it's 2 times a whole number in 6k squared plus 3k plus 1. That's odd. Okay, next one. Now, so we've checked and it works for all even numbers, but we need to check for all odd numbers. Now I can say let n equal 2k plus 1 to be an odd number, but actually just looking at what I need to sub into, I'm going to choose 2k minus 1, which is also an odd number. It's going to work out a bit neater because it's going to subtract the 1 in this bracket away. It's just going to make my expanding easier. So always look out for how you can simplify your kind of algebra skills that you need to do. So it's 2k minus 1, and then it's plus 1 cubed minus 2k minus 1 cubed. Now of course if you did do 2k plus 1 it will still be completely correct. But I just think this is a slightly more efficient way because it means that this bracket here becomes so much easier to expand, and this one is just as sort of easy really. So this is 8k cubed, and this one I'm going to get. Now should I do the binomial again? I think I should. And let's just put a big bracket here. So it's going to be 2k cubed plus 3 lots of 2k squared times by minus 1 to the 1. And then we're going to have 3 lots again because of the Pascal's triangle. 2k to the 1, and this is going to be minus 1 squared. And then for the final term, let me just shift it over slightly so we've got some space, will be just 1, 2k will be to the 0, and minus 1 will be to the minus 3. To the 3, sorry. Okay, there we go. Just using binomial expansion there to expand that triple bracket. Of course you could do it by literally just writing out the 3 brackets and expanding, but I think this is probably quicker. This gives me 8k cubed. There's going to be a minus here, so it's minus, there's going to be 4 because of the 2 squared, times 3 is 12k squared. Here we're going to have a plus 6k. The negatives will cancel because it's negative squared, and that's going to be a minus 1. Okay, and then let's just be very careful, because classic mistake is not to apply that negative to everything inside that bracket. But the first thing we do is we cancel those, and we're left with that negative still needs to apply, so it's positive 12k squared, it's negative 6k, and then it's positive 1. And this is equal to 2 lots of 6k squared minus 3k plus 1, which is odd. We need a conclusion statement, and that is we have proved that n plus 1 all cubed minus n cubed is odd for all even numbers and for all odd numbers. Therefore, it is odd for all natural numbers. Beautiful. Okay, welcome to the beast. Definitely the hardest question on the paper, and that is to do the quotient rule and then to somehow rearrange it into this absolute monster. So, for the quotient rule, we say u is the numerator, and we say v is the denominator, which I'll write like this, to the power of a half. And then we're going to have to use the product rule in order to differentiate this first one. So for the product rule, I would split it up nice and clearly into the 2 different functions. And I would differentiate the yellow one first to get 7 and multiply it by the blue one. And then I would add, and I would keep the yellow one the same and multiply it by the derivative of the blue one, which is just e to the x. Okay, great. Now we can differentiate v, and we can do that by the chain rule. So what we're going to do is, I'll just do it over here so it's nice and clear what we're doing for those that might not be so savvy with the chain rule. Then we could say that y is equal to u to the half, where u is equal to e to the 3x minus 2. We can differentiate both of these, so that one in terms of u, you get a half u to the minus a half, and this one with respect to x, when we differentiate e to the 3x, we get 3e to the 3x, and minus 2 goes to 0. So dy by dx is du by dx multiplied by dy by du multiplied by du by dx. So it's these two multiplied together, which gives you half u to the negative half multiplied by 3e to the 3x. So what is that going to look like? Well, I can put the 3e to the 3x at the front, times by half actually, so it'll be 3 over 2, and then times by u to the negative a half, and u is this. So we just need to multiply through by e to the 3x minus 2 to the negative a half. Okay, that's all good. Get rid of this working here. That was just me doing the chain rule on the side. Of course, in practice, to save time, what you would do is just times the power down. You would write the bracket out, drop the power down by 1, that's why you get the minus a half there, and then multiply by the derivative of the bracket, which is 3e to the 3x. Okay, now we are in a position where we can use the quotient rule. So the derivative function is v, which is e to the 3x minus 2 to the power of a half, multiplied by du, which is 7e to the x plus 7x e to the x, minus u multiplied by dv, which is 3 over 2 e to the 3x e to the 3x minus 2 to the minus a half. And that, of course, is all divided by x, not x, v squared. And v squared looks like this. And of course, when we take a power and then of another power, we can times those powers together. And that half times 2 gives me 1. So we're just left with this. Okay. Okay, so the numerator looks horrible. The denominator doesn't look too far off, actually. So let's just think about what do we have to multiply our denominator by, which is to the power of 1, to get the denominator over here. Well, we've got to multiply it by a 2, and we've also got to multiply it by e to the 3x minus 2 to the power of a half. Because then when I add that to the power here of 1, then that's going to give me to the power of 3 over 2. So that's exactly what we're going to do. We're going to multiply the top and the bottom by this. And that's going to give us the correct denominator, which is at least a decent place to start. Okay, so let's scroll down, get some more space, and then let's do that. So multiplying through, first off, if I multiply this by the first term at the top, well, I'm going to multiply it by this part, and the two powers are going to add, so we're going to get to the power of 1. So that becomes e to the 3x minus 2 to the power of 1. We also need to multiply by 2 as well, and then we can just keep this part of the term the same. And we've multiplied that first term through. Okay, now the second term. Well, once again, I can spot here that I've got this part, and when I multiply it by the blue here, then again, the powers are going to add. We'll get minus a half plus a half, which gives 0. So anything to the power of 0 is 1. So in fact, it's just going to cancel that out. And also, the times by 2 is just going to cancel out this 2 here. Okay, so this gives 7x e to the x multiplied by 3e to the 3x. And then on the denominator, we're going to get 2. And we've engineered this, haven't we, so that this is going to give me to the power of 3 over 2, because the powers 1 here and a half here will add to make 3 over 2. Perfect. So now the denominator is set, we need to look at the numerator. And the numerator, the thing that stands out is they've taken out a factor of 7 e to the x. So we need to take out a factor of 7 e to the x from both of these terms. Okay, well, I can see that this bracket here has the factor which we can take out. And for the second term, you can see also there's a factor there of 7 e to the x. So let's take that out. So if I take out a 7 e to the x, then the first term is still 2e to the 3x minus 2 multiplied by, now I'm going to take the factor out of that bracket, which is going to give me 1 for the first term in that bracket plus x for the second. And we've taken a factor out of all of that terms because it's all multiplied together. And then minus, here when I take it out, I'm just left with x multiplied by 3 e to the 3x. So that becomes 3x e to the 3x. Okay, great. And that is all over, again, this same thing. Okay, so I think now we are good just to expand out, really, and then we should get 2 terms which have e to the 3x in it. Okay, so, oh, actually, hold on a minute. That 2 here can just pop into this bracket, no? Is that going to work out nicely? No, that's not going to work out nicely. Okay, never mind. Be so lucky. We need to expand out then. So 7e to the x. This is going to give us 2e to the 3x plus 2x e to the 3x minus 4 and then minus 4x. So I've just expanded out this this double bracket, which is also times by 2. And then minus 3x e to the 3x. Ugh, this is tiresome. Okay. Now we can collect like terms, of which there is just these guys. These guys are exactly the same. That becomes minus. So we have 2e to the 3x minus an x e to the 3x minus 4x minus 4. Not sure why I turned them around there, but hey ho, done it. Okay, and then let's just carry on over here, so I don't have to scroll down. And then this, we need to take out an e to the 3x out of those first 2 terms to get 2 minus x, and then minus 4x minus 4, and I think that is done. Wowza. What an algebraic question. Now, we need to check. It says a and b are constants to be found, so therefore I am actually going to write down what they are, and they're both minus 4. So we can say a is equal to minus 4, and b is equal to minus 4. Beautiful. Okay, part B. So just from the previous question, a was minus 4 and b was also minus 4. So part B, it says that show the x coordinates of the turning point. So this is the derivative function. So if we set it equal to 0, then that's where the turning points will be. And because it's a fraction, we need to be concerned about the numerator being 0. So that tells me that 7e to the x, open brackets, e to the 3x, 2 minus x, minus 4x minus 4 needs to equal 0. Okay, so e to the x can never be 0. So essentially, we're not going to get a solution from that part, that factor. So we will get a solution though if this bracket in the middle is equal to 0. So e to the 3x, 2 minus x minus 4x minus 4 needs to equal 0. So we can see here that we need to make x the subject of this equation. So we need to multiply out to get 2e to the 3x minus x e to the 3x minus 4x minus 4 equals 0. Let's bring all the terms of an x in it to the other side and make them all positive. So it's just going to make it a bit easier. So that's going to give me a positive 4x and a positive x e to the 3x. We can then take out a factor of x, and thus making x only appear once in the equation. And then finally we can divide through by that factor, and just writing it the way round they want it, like so, gives me x. Beautiful. There it is. 2 marks. Job done. Okay, still more to this question. We got the equation that was found in the previous part, being the solution to the turning points. It has 2 positive roots, and the student uses this iteration formula. Sounds good. In an attempt to find the approximation for alpha and beta. Diagram 1 shows a plot of part of the curve, okay, and also the line y equals x. So we're going to do x equals g of x type iteration. Draw a staircase diagram to show that the iteration formula starting with x equals 1 can be used to find an approximation for beta. Okay, so when you substitute in 1 into your function, it will give me a y value such like this, and that y value might have a value of, I don't know, 3. So if I then go over to the line y equals x, like so, then it means that this x value down here will also be 3, because I've just come from the line y equals x, so where the y is the same as the x. So therefore that acts as our next x value to sub in. So what I could do, rather than going back down, is I could just go back up and sub in this next x value, and I get something like this. And let's say that value, if I come across, is like 4, then I can go across to the line y equals x, and that will give me, or tell me the position of the next x value. So I come down here, this will be 4, because it's on the line y equals x, the y is equal to the x. And as you can see, we're getting closer to beta. But from that next one, I sub in. So I sub in, hit the curve again, and then I go back over to y equals x, like so, and we're just going to converge on the root by using a staircase in this instance. Okay, so we don't need those. All we need is what we've just drawn on the diagram there. Perfect. Okay, so now we need to actually use the iteration formula. So I'm going to have to get my calculator out to do that. And I'm going to go into menu, and I'm going to go to 1, and I'm going to say that the first x value is 1, so I press 1 equals, and then I'm going to set up the formula, which is as follows: 2 multiplied by e to the power of 3 times the x value, which I'm going to use the answer button so that I can get the next iteration nice and easily, minus 4 over e to the power of 3 times, again, the answer button, plus 4. I press equals, and there is my value for x2. So I can say that x2 is equal to 1.502, and that's to 3 decimal places. And then it says find the value of beta, so therefore I can just keep pressing equals, and it's going to give me the next x value, so x3, and then x4, x5, x6, 7, 8, and so on and so on. Just keep pressing equals until you get no more repeats, until it just keeps repeating, and that is as close as your calculator is going to get you. So beta to 3 decimal places is 1.968. Perfect. Okay, lovely. So the final part says using a suitable interval and a suitable function that should be stated, show that alpha is correct. Is this correct to 3 decimal places? Okay, well, let's remind ourselves what alpha is, because that's going to dictate what function we use. So alpha was one of the 2 positive roots of the equation, and if we go back to the previous question, then it said that this equation here, which alpha is a root of, gives us the x-coordinate of the turning points. So when do the turning points happen? Well, they happen when this is equal to 0. So if I substitute alpha into the gradient function, then we should get 0. In fact, it's this part, remember, which is going to give us our 0. So if we substitute our alpha into that, then that should be 0. So we could check either side of alpha, and we should expect to see a change of sign. Okay. So let's just write down what that part of that function was. It was e to the 3x 2 minus x minus 4x minus 4. Okay, so this is the part of the gradient function, the f of x, which needs to be 0 in order to give us a turning point. So if we substitute in alpha a little bit below and a little bit above, then we should hopefully get a change of sign as it changes from positive to negative or vice versa. So what I'm going to do is I'm just going to press 0.4315 equals, and then that way I can just go to e to the power of 3 times answer multiplied by 2 minus answer minus 4 lots of answer minus 4. Okay, great. So that gives us, this fills me with lots of confidence, because that is a tiny number and it's very close to 0, but also it is negative. So now we are hoping that the other side of alpha is going to give me a positive answer. So I'm going to change this to 2.5 equals, and then I'm just going to have to write that out again. E to the e to the power of 3 answer, close brackets, 2 minus answer, and then minus 4 answer minus 4. Okay, perfect. That gives me a really small number, but it's positive. Okay, so finally we say that as there is a change of sign and g of x is continuous, alpha is equal to 0.432 correct to 2 decimal places. No, 3 decimal places. And that's a wrap. I hope you enjoyed that. I hope you found it useful. If you did, please like, share and subscribe. Check out that brilliant link. That really helps out my channel. And I will see you in the next one. Bye for now.